Okay, today in class we're going to be talking about the substitution method and elimination method for solving a system of equations. Now, we briefly talked about systems of equations, solving them by graphing, where we would graph the two lines, and we would find the solution, which was the point of intersection where the two lines would cross each other. So we're going to do the same thing, except we're not going to graph. We're going to do it with algebraic methods using substitution and elimination method. So first we'll start with substitution method. Now, substitution property of equation says that if two things are equal, we can replace one thing with the other. So on this problem number 1 right here, we see that we have two equations and they have two different variables, an x and a y. I cannot solve for either equation for each variable because I have two totally different variables. But I can, since it's a system, I can use them with each other. Now, notice on number 1 it says y equals 3x. So that means anywhere that I have a y in this system, I can replace it with 3x. Well, the next equation says x plus 2y equals negative 21. So there is a y in that equation. And since I know that y equals 3x, I can put 3x in the place of the y. So that's what I'm going to do. I'm going to copy the second equation, x plus 2. Now, where it had a y, I'm going to use parentheses, and I'm going to substitute the 3x in the y's place. And then we'll continue copying the equation. Now my equation has all x's in it, and I will be able to solve that equation for x. So 2 times 3x is 6x. So x plus 6x equals negative 21. And then x and 6x, since they're on the same side of the equal sign, are like terms. I combine those and I get 7x equals negative 21. And then to continue solving, I divide by 7 on both sides. X equals negative 3. Okay, so now that I know what x is, I can finish plugging into my system and solve for y. Well, the very first equation told me that y equals 3x, and now that I know that x equals negative 3, I can substitute that in for x. So y equals 3 times negative 3, and 3 times negative 3 is negative 9. Y equals negative 9. Now I have an x and a y value for my solution, and we are going to write our solutions in ordered pairs. So you have an x value and a y value, so you always do it x, comma, y. So if we were to graph these two linear equations and graph those lines, they would be intersecting at the point negative 3, negative 9. All right, the next system of equations we're also going to solve by substitution. This one tells me that y equals 3x plus 2. So anywhere I see a y, like right here, I can substitute 3x plus 2 in y's place. So that's what I'm going to do right here. I'm going to copy the second equation, x plus 2. And where they had a y, I'm going to use parentheses and distribute 3x plus 2. And then equals 11. So where I have in parentheses is where the y was originally in that second equation. So now I'm going to distribute. So copy my x. 2 times 3x is 6x. 2 times 2 is 4. And then my like terms right there, x plus 6x equals 7x. 7x plus 4 equals 11. And then I subtract 4 on both sides. 7x equals 7. Divide by 7. And x equals 1. So there's one of my coordinates. And then I can plug that in and solve for y. So y equals 3x plus 2. And now that I know that x equals 1, I can say that that is 3 times 1 plus 2. 3 times 1 is 3. And 3 plus 2 equals 5. So 5 is my y value. So I put them in an ordered pair form. 1, 5 is my solution to this system of equations. Let's do one more. This one tells me x equals 2y minus 6. So where I see an x in the second equation, I can replace that with 2y minus 6. So I'm going to say 4 parentheses. Then I'm going to insert my 2y minus 6 plus 6y equals 4. So now I have an equation with all y's, and I can solve it for y. First, I need to distribute. 4 times 2y is 8y. 4 times negative 6 is negative 24, and then copy the rest. And then these y's on the left-hand side of the equation are like terms. 8y plus 6y is 14y, minus 24 equals 4. Then I continue solving. I'm going to add 24 on both sides. That gets me 14y equals 28. And then I divide by 14 on both sides, and y equals 2. And now I can plug that in to find x. Well, x equals 2y minus 6. So x equals 2 times 2 minus 6. 2 times 2 is 4, minus 6 is negative 2. So that's the ordered pair, negative 2, 2. X goes in the x place, y goes in the y place. So that is how we use substitution. Next, we are going to use elimination method to solve a system of equations. Now, when we're using elimination method, it does exactly what it says it does. It eliminates a variable. It cancels out a variable. So you want a variable that cancels out. And when I say cancel out, I mean they add to make 0. And we do that when we have opposite coefficients. So when we're using elimination method, we want opposite coefficients. Remember that opposites are when numbers have opposite signs. One's a positive, one's a negative. And remember that a coefficient is the number that goes in front of a variable. So opposite coefficients would be like these x's right here. I have a positive 2x and a negative 2x. If I were to combine those x's, I get 0x, and 0 times x equals 0. So what we're going to do is we're going to draw a line under the system, which is the two equations with the two variables. And since they have opposite coefficients here, they will cancel each other out. So then I continue on with my y's and then my constants. So I will just combine like terms going down the columns. Positive 3y plus 5y equals 8y, so I will write that down there. And then I do my constant terms that don't have variables. 11 plus 13 is 24. And now I'm left with a little simple equation, 8y equals 24. So I'm going to divide both sides by 8, and y. There's one of my coordinates. So that's the y value. To get the x value, you will just plug 3 in for y from one of your original equations. I'm just going to use the top one. I still don't know what x is, but now I know that y equals 3. So where they have a y, I'm going to substitute in a 3 just like I did earlier. So 3 times 3 is 9. So 2x plus 9 equals 11. Subtract 9. 2x equals 2. Divide by 2. And x equals 1. So the ordered pair, 1, 3, is the solution to this system of equations. So again, on elimination method, you're looking for variables that have the same number coefficients, but they're opposite signs. Let's try to do one more. Notice on number 5, the y values already have opposite coefficients, so they are ready to eliminate. So I'm going to cross those out because they add to make 0y. Then I'm going to add my x's, and we'll leave a space right here for my y's. And then I have negative 30 plus 10, and that's negative 20. And then ignore that space in between, and then just divide by 2, and x equals 2. And then you can plug that in for one of your originals. I'm going to use the bottom original equation, the 3x plus 4y equals 10, because those just have smaller numbers, and it will be a little bit simpler to work with. So 3 times negative 2 plus 4y equals 10. 3 times negative 2 is negative 6, and I'm going to copy the rest. And then I'm going to add 6 to both sides. So 4y equals 16. Divide by 4, and y equals 4. So that ordered pair will be the ordered pair negative 2, 4 for this system. Now this is all I have time for this video, and so stay tuned for part 2 of this video on systems of equations. Have a good day.